This is a short talk made to get you a bit excited about FRP. Functional reactive programming or reactive programming, these are two different things, but today we're going to talk about mainly reactive programming. How many of you have some experience with it? All right, so some people already had some exposure. So reactive programming is a hot topic as of late, especially with such things as the Reactive Manifesto, and I think it was Coursera made a massive course in Scala by one of the authors of the author of Scala, Martin Odersky. So it's kind of it's getting traction. I'm going to talk about functional reactive programming applied in JavaScript, and it's going to be very practical. I'm not going to go through theory, which there's a lot. So I am. Oh, sorry. Not on. Yeah, I'm Sergi Mansilla. That's my Twitter. That's my GitHub. I have a lot of projects. I collaborate on many open source projects. Before, I used to work at TomTom, making the WebKit UI of the devices. There's 3 devices of TomTom that use JavaScript to draw the UI. Now they're back to using Android. And then I worked at Cloud9 IDE, which is an IDE online that runs in your browser. Currently, I'm working at Telenor. That's a Scandinavian telco, but I don't do anything related to telecommunications. I work on Firefox OS with Mozilla. And first of all, let me apologize about the shameless link baiting that I done with the title. I mean, conquering time with FRP is pretty grandiose and ambitious. But my first title was something like that, so we should be grateful. Tame your racing code with this one weird trick. So we're going to talk about time anyway. Human beings have time hardwired in their brains. We know about our appointments. We know what happened yesterday. We know about our birthday. Everything is about time. We have to meet a friend at a particular time. A specialization of human beings, which are JavaScript developers, have hardwired async in their brain. That's for many reasons. JavaScript has only one thread. Most of the interactions you do in JavaScript have to be asynchronous if you don't want to block UI. You probably are familiar with the reasons. The thing is, JavaScript deals with a lot of asynchronicity, but it didn't come with any way to make it easy. So we came up with all kinds of constructs to deal with that annoying time concept. We came back with callbacks, which is the rawest, most basic Node.js chosen way of dealing with asynchronous stuff. You just pass functions and call them when the function that executed before is finished. Promises are an improvement. I mean, that's an opinion, but are an improvement over callbacks because you at least have a handler on the time-related task. And now generators are coming. Generators are cool. They're going to change everything about JavaScript because they're extremely powerful and they allow you to go back to a synchronous way of programming, kind of. Then we have events. But in reality, everything you do asynchronously could be called events because whenever a function comes back is an event. Whenever a promise executed then clause, it's an event. So it's all events. It's all things that happen and you want to do something when they happen. We use events to deal with all asynchronous tasks. So I will start with my first example being a JavaScript event. For those of you that program JavaScript, usually this is a very familiar code. That's an event listener for a click event. What it does is count. It logs the coordinates of clicks that happen on the right side of the screen, but only the first 10 clicks. Then it stops logging. That's all we want to do. But we don't think about it anymore because we do it all the time. But look at this code. I just want to log clicks on the right 10 times. This is a lot of code. Why are still micromanaging code? This kind of code especially. It's not that I want some precision because it's a very performance-sensitive task. There's absolutely no reason why I have to write so much. So let's go back to the code. What I really want this code to do, the really meaningful lines, are if clicks is less than 10. That means like only log 10 clicks or only do it for 10 clicks. If the coordinates are the right ones, which is right side of the screen, then just output, do some side effect and output the X and Y coordinates. That's all I want from that code. Now, you might be thinking, well, that's not that bad, it's not horrible code, but now I want to add another condition to that code. And I want that all this only happens, that it only logs the clicks when the A key is pressed. Another simple condition. That's what happens to the code. And if you have a better way, just tell me. But what I have to do is add 2 more event listeners, one for key down, the other one for key up. Add an extra variable is A pressed, which is initialized to false. Whenever A is pressed, whenever I do key down, is pressed, it's true. And then if then I click, I check for that condition, everything works. But this is a lot of code and very complicated. And the thing is, I wrote that, probably I'm familiar with it, but if I take this computer, you've never seen that code, and I give it to you, you will need some minutes to know what this is doing or why am I doing it. And that is because nowadays, at least in JavaScript and for the web, we still code the how instead of the what. The what is what I want to do. The how is how the computer should do it. So this code, I'm telling the computer exactly how to do that. I'm telling him, okay, now register this event listener, then remove it if the clicks are less than 10. It has nothing to do with the task at hand, which is like log the first 10 clicks. Programming should be more about the what. Programming for these kind of tasks. I'm not talking about programming microprocessors, which you have to be very precise, very fast. For this kind of tasks, we should be able to just say, like, log the first 10 clicks as succinctly as possible, without leaving memory leaks, because when you don't remove an event listener, it's a memory leak and stuff like this. So programming should be more about the what. That woman knows well. The other thing is state is dangerous. How many of you are familiar with functional programming? All right. State is dangerous. The more state you keep in an object or whatever style you program, the more state you keep, the more risks of somebody else in your program modifying that state and ending up with unpredictable consequences. It's dangerous. And we're talking about a very small program here. We already have all this state. Everything that's circled out, it's state. So I need a variable to register the clicks outside my event listener. If somebody else in another part of the program modifies this variable, I'm screwed. The program doesn't work as I expect anymore. Then I have to take care to update these clicks. I need another variable to register whether A is pressed. And then I have to modify it to true or false all the time, depending on whether A is pressed. This is not good. We have the smallest program, and we already have all this state risking. For example, here I don't reset clicks ever. There's already a bug. You could count it as a bug, but it's not really, but it is. Depends on how this program evolves. These are potential bugs that will happen at some point. Then there is another thing which I call event limbo. It's not that kind of limbo, but if you have to take something away from this talk, it should be the following. This record exists. David Hasselhoff, do the limbo dance. That really is out there. Event limbo, what is it? Our poor events are one of the most important parts in JavaScript, whether you do Node.js, whether you do front-end, back-end, it's all about events. But they are not really first-class citizens. An event, first of all, it's stateful by default. An event, you cannot not do any side effects for an event. It doesn't make sense. Whatever value you return from an event doesn't matter. You can return whatever. Nobody will pick up this value ever. An event just is there to do side effects. Also, you cannot pass an event stream, I should say. You can pass the event object, but what do you do with this? Not much. What you want is to isolate, first of all, to have a handler to the event, because in this example, when I click is very synchronous code, that's for sure. But imagine that was an AJAX request. From the moment I send the event, let's do it with click. From the moment I click to the moment my function gets executed, I don't have a handler to the event. So I just hope for the best. I just say, like, listen to click. Whenever you click, just execute this. In case of AJAX, I would do like, do this request. When it's back, do this. In the meantime, I don't know where this function is. I don't know where the callback is. The developer is kind of helpless until the callback is executed. No feedback, nothing. But isn't that the problem the promises try to solve? Kind of. So promises are good for solving asynchronous operations such as querying a service with an XML HTTP request where the expected behavior is one value and then completion, or go to the next promise. So something like that. Here, on the upper side of the diagram, I have the synchronous version, which is just assigning functions to variables. On the right of that, we have the promise way. We do f async or g async, and then we execute when this is completed. So what I'm going to introduce today, which is RxJS, it's a reactive framework that allows us to do what promises do, but with streams of events. The equivalent will be, imagine that you have an array of stocks. That's the lower part of the picture. You have an array of stocks, and you just filter by symbol, the Facebook symbol, and then you map it to whatever quote that that stock has, whatever value has. And then when you have that, you can iterate, right? How many of you are familiar with filter and map operations? Most of you. So what's happening here is that on an array, we filter whatever has the symbol Facebook, returns true, so only the values that have the symbol Facebook will go to the next stage, which is the map, and the map replaces the symbol, the string FB in that case, by the quote. That's pretty awesome of arrays, but what RxJS allows us to do is the same, exact, that's real code, with asynchronous retrieval. So in that case, stocks is not an array. Let me see. This stocks, that's not an array. That is what we call an observable. This is an asynchronous operation that has not happened yet. This is an AJAX request or user input, whatever. Whenever it happens, we'll get the results. So to understand that better, what I'm trying to say is that reactive programming and RxJS in particular is all about stream of events. So how does an event work? This is my way of drawing what happened when a user clicks the screen. So whenever I keep clicking the screen, the computer gets this. Gets one click, then another one, then maybe 1 hour later, another one. What does this look like? What if we put some brackets around it and put some commas between the clicks? That looks like an array. What is an array? An array is a sequence. So what we want to do is to see our events. And by event, I not only mean JavaScript events, but anything is synchronous as a sequence. not as a single event. We don't want to deal with this click and this click. We want to take the whole sequence of clicks and operate on it, and be able to take this sequence, and pass it around, capture it, and clone it, and do stuff with this sequence that cannot be done in plain JavaScript. The best programming style to deal with sequences is functional. Functional programming is very good at dealing with lists of items, transforming them, passing them around. So we have, in JavaScript, we have stuff like this. We have an array of numbers. We filter it by the ones that are divisible by 2. We add a string, and we log it. This is functional. I'm passing, at no point there's state in this whole operation. There's no external state. I don't keep anything. I just keep passing and transforming the initial sequence into a final output. I'm using ES6, by the way. That's why you don't see function names or anything like that. I'm using arrows. It's much better for presentations. Code fits everywhere. Very nice. If there's any doubt about the code, just let me know. So we haven't solved anything yet. This is very obvious. This is synchronous code and very easy to grasp in that way. What is good at discrete async event stream processing is FRP. If you look for FRP online, you might not find the right reference at first. You will find final resting place. That's true in Google. Fantasy role-playing, that's not what I'm talking about. I'm talking about functional reactive programming. And there is a very cool concept or visual image that shows reactive programming in a second. How many of you have ever used a spreadsheet? Most of you, obviously. We all have. In Excel, you might think whatever you think in Excel or whatever spreadsheet you use, you might think anything about that program. But Excel got one thing amazingly right. First of all, is the most, people say like JavaScript is the most extended programming platform in the world because all the browsers run it. Node.js, everything starting to move to JavaScript. No, the most extended programming platform in the world is Excel. Everyone programs in Excel. My dad programs in Excel. Just puts formulas and things work. And as a developer, you might make fun of it, but Excel has one amazing feature, which is this. In Excel, you change values, and a value that has a formula referring to these values changes automatically. The C cell has just I think the addition or the multiplication of A and B. Whenever I change A or whenever I change B, C changes. I don't have to tell Excel when A and B changes, A changes or B changes. In any case, update yourself by adding these two results. Nobody has to do that. You just know that you just put A plus B. Whenever you change it, it works. Nobody instructed Excel. Nobody registered an event. Nobody told the program step by step what to do when cells change. And that's very easy to grasp. Imagine that Excel didn't work that way. Nobody would use it if you had to do any programming. That's why it's so popular. That's not what I wanted to do. Yeah. So why don't we program like this? Why don't we at least have the possibility to program like this? Why do we have to painstakingly tell everything that's going to happen, deal with every race condition, every edge case that exists, and only then our program kind of works? And whenever I want to add a feature, it's more painstakingly adding stuff to the code. So what do we want to do? And one of the hardest things in computer science right now is deal with values that change over time, properly, without complications. RX, this is the symbol, this is the logo for RX. RX is a platform that was made by Microsoft, amazingly enough. sometimes it's easy to forget that some good stuff comes out from Microsoft still. RX was made by Microsoft Open Technologies and open sourced. And the cool thing is that here I'm talking about RxJS, JavaScript, but almost for every language there is an Rx. There's an Rx for Java, for .NET, for Ruby, for Lua, for all kinds of languages. An Rx helps us compose asynchronous and event-based programs. Let's take our previous example. There's 3 things I wanted to do with my clicks. I wanted to limit them to 10 clicks, limit the whole thing to 10 clicks. I don't want anything else. I just want the first 10. I want to filter them by coordinate, and I want to eventually print the coordinates. This is our previous code. This is how you do it with Rx. In Rx, we say from the event click in the document, filter by these coordinates, take 10 of these results, and once this is done, subscribe. What is happening is the first line creates an observable, which I will get back to it in a moment about what it is. From that observable, we filter. So we create another observable that contains the filtering from the first one. Create a final observable taking only the first 10 results, and actually kick off the computation. So until I subscribe, nothing happens. I'm just declaring what I want to happen when there is a subscription. Now, Rx has 2 main types. There's other types, but they rely on those, or are specializations of these 2. There's an observable and an observer. You can think of the observable class as a push equivalent to iterable. So an iterator in other languages, in JavaScript we still don't have them, but in other languages just an object to which you ask next item, next item, next item. This iterator contains a collection. You ask for the next item until it says like there's no more items, and then it's completed, or throws an error in the meantime. The observable is like this, but instead of pulling from the collection, it gets the items pushed. So the observable would push to the observer whenever it has items. Whenever it receives a request, whenever the user clicks, it will push to the observer. The observer doesn't have to do anything, just has to wait. There's only 3 methods on an observer, which is onNext, onError, and onComplete. Same kind of methods as in an iterable, but with the particularity that they get called. So the observable type adds the ability for the producer to signal to the consumer that there is no more data available. In that regard, you can think of the observable. It's a very simple concept. You can think of the observable as a fusion between iterators and the observer pattern, the good old observer pattern. Right? Observer pattern, you just have one object that has all these listeners. Whenever something happens, call the listeners. But the observer pattern doesn't have the concept of onComplete and onError. It just keeps passing stuff. The iterator has this, but what it doesn't have is the ability to push values to the customers. The customers have to ask for them. So this a little bit more code. I try to keep the code simple. RxJS has a lot of operators or methods. Okay, here I show range. You have all kinds of tools to manipulate, create, and transform sequences. In that case, it's very simple. I make a range from 1 to 5, and I subscribe to this. And if you see in the subscribe method, I pass the onNext function, which is the first one, onError, second one, and the third one is completed. Of course, no errors will happen, so the output I get is all the values of the range and then onCompleted. So this is exactly what we expect. The important part here is I am assigning this to a variable. From this variable, I can pass it, I can clone it, I can create extra observables that don't modify the parent. This variable is final, but at the same time it's a stream that changes whenever new values come. Let's see something more interesting. This one is another example. I create an observable from a mouse move event. I create another observable from this mouse move event, but this one maps the event to an object with the coordinates. I create yet another observable called mouse side, which maps the first mouse move to it checks the coordinate and outputs either right or left. And then I subscribe to only the coordinates. This will output objects with coordinates. This will subscribe to the mouse side. This will output right or left, depending on wherever I move the mouse. And this will be updated real time. These two observables, the three of them, will be completely independent. They will update. I don't have to do anything else to log all these coordinates and to do all this stuff with the mouse. Now, real world example, or kind of. This might look like a lot of code, but it's very simple. The first function just retrieves, creates an observable that retrieves a term from the Wikipedia. You see I have the URL, so you pass it a term, like whatever, Amsterdam. And I create an observable that has, instead of the methods we've seen, it has get JSON peer request. This is some normal query selector stuff. Now this is pretty cool. KeyApp will contain the stream of events of KeyApp. But not only that, I will get the target value, so the value of the input field, where the text is longer than 2. I don't want to retrieve 1 character. I will throttle 200 milliseconds so that the user, if a user types very fast, I don't send a million requests to Wikipedia. And I will only accept distinct values. So if I move the cursor keys, which don't change the value of the input box, I don't want to send new requests. So in 3 lines, we're filtering, we're throttling. Throttling is hard in real JavaScript. And I will only accept distinct values. And now on the other hand, so here I get the input of the user. On the other hand, I get on KeyApp, so I subscribe to this KeyApp event, and that we call it searcher, which will be another observable. We map each value to the actual Wikipedia retrieval. So all this looks synchronous, but it's highly, highly, highly asynchronous. This registering the keyapps from the user, searching in Wikipedia. Then we have another method called switch latest, which only will accept the latest result that arrives. What I don't want to is to, some of the terms, it happens with asynchronous, and that's one of the hard things. I can keep typing on a search box, and the latest result is not the one that I was asking anymore. So it's not the one that it corresponds to the text I'm putting. Like asynchronous is chaos, so anything can arrive, right? Switch latest ensures that I only get the result that is the last result that I want. So whatever the text corresponds to, all the others are discarded. And I also just filter by data length too, which means where we have data, because that's it returns an array. We subscribe, and we just do whatever we want with the code. And that's I have the web page around, but I don't like demo effects. So that's what happens. And there's no more code. Like there's only the HTML code to make the input. That's all. To make real requests to Wikipedia, real-time, throttled, distinct, making sure that no mixed results come. Another cool side effect comes from the fact that I can abstract stream of events into variables. And is that this code usually, or what this code does, will be hell to test. Asynchronous code is very hard to test people start making mockups with set timeouts and stuff like this. It gets hairy very, very, very quickly. And almost always there's bugs in the test as well. So the cool thing is that you see the first term, search Wikipedia, which does a real JSON request. I can just do that, just make up an array. But because it's an observable, everything will just work and still keep asynchronous. There's even another thing that I didn't put on the slides, which are, I'm not talking about it on the talk because it's more an advanced topic, but there are schedulers. So what I can do is any observable, I can attach a scheduler to it and tell it how to behave in time. So even if I have for example, if I do an observable on an array, the default scheduler is the current thread. So it will go instantly, like we expect, synchronously. But maybe I don't want this array to behave synchronously, and I can attach a scheduler that separates the results by 200 milliseconds. I just attach a scheduler, 200 milliseconds, and everything will be asynchronous. Then we have a test scheduler that simulates asynchronicity. So in that case, in this from array, the second parameter, I could just attach scheduler that delays that, or that introduces, I don't know, random asynchronicity, and we could test for asynchronicity as well. So testing becomes very easy. No mocking, no anything, just changing to a different scheduler, and you can test anything. We saw from array, from event, there's more, and some that I missed. You can create observers from callbacks, from node callbacks, because of course, you know, all this is very nice, but you will have to deal with third-party libraries. You might want to test it on a project you have, but you don't want to convert anything to the RxJS religion. So you can convert to and from observables, from node callbacks, from event patterns. You can define your own observables, all kinds of stuff. I want to show another example that I think is pretty cool, because until now we haven't seen much UI. The input one was a bit of UI, but this one is really nice. So to program in reactive programming, you have to change a little bit the way you think. You have to think in sequences. So a mouse drag and drop is a sequence. There's different sequences. There's the sequence of mouse down, there's the sequence of mouse up, and there's the sequence of mouse move. These are three different sequences that happen in time, like events happening. So I can make a code that says, you see here I subscribe to the events. This is not very interesting. Mouse drag is a mouse down. Select many is basically a concat all in an array. So imagine you have an array of arrays, and it just normalizes it. So it makes it to an array with values. Takes out all the inner arrays. Select. These are coordinate calculations. And then I can do like return the mouse move, but take only the mouse move until there's a mouse up. So what is happening here, I'm composing a stream of events. I'm saying like, subscribe to mouse down. Whenever a mouse down happens, inside the mouse down event, check the mouse moves. And only do all this until there's a mouse up. So take until mouse up. Remember that before we use take to take values, to take amount of clicks, we can also use it to take mouse up events, because both are observables. So when you think of in sequences, code becomes that easy. And that code, what that code does is, the following. Now, here. Let me see. Yeah, I have it here. It doesn't feel very well. The code you've seen is, where's my mouse here? It's this. It's a bit shrink, but we have the mouse drag defined here, mouse move, take until mouse up. What happens is that I just have normal drag. Cool thing is, have a normal drag without, where's my mouse? Here. There is no state. There is no state outside mouse drag. I'm not keeping my variables around outside the closures to control when is the user clicking, when is the user unclicking, and this kind of stuff. There's no state. It's all functions and observables being passed. I don't have to unsubscribe. I don't have to do anything like that. I just deal with sequences. RxJS does everything in the background. One thing I always get asked is about performance. As a JavaScript developer, you probably know this is the normal array example, no observables here, normal JavaScript. Whenever you do that, this is very easy or very nice with 10 items, but what's happening here really is that. So the first filter function loops through the whole array. The map function loops again, and the final for each to print the items loops again. So if instead of 10 items I have 100 million items, that is a performance bottleneck. So whenever people see this observable stuff, that everything is a sequence that we iterate on, that's the first question, like how performant is that? That can be good. And whenever this happens, I take my cat slide out. This cat is pushing a watermelon out of a lake, and your argument is invalid. What happens here, this is the observable example. And as I said before, if you didn't catch it, we convert it from the array, we attach a filter function, we attach a map that multiplies, we attach another map that composes a string, but all this has not executed anything yet. It's all declarative. The only thing that executes is subscribe. But what you have done in this up until the subscribe, what RxJS has done in the background is compose internally so that there's only one loop. And this one loop executes all the instructions. So it's very, 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 very fast. As fast as looping one time with the overhead of calling functions, but that doesn't really count. So it doesn't process the items for each iterative method. The things to take away are that reactive programming allow you to make the events into first class, give events the power that they require. Events are nice, but they get messy. What we want is to be able to pass stream of events around easily, iterate over them, transform them. We want to compose them as well. We want to just filter, map, do this kind of stuff over all kinds of event streams. And encapsulate. We don't have state. We want things to be on their own and not manipulate state. Events, inherently, whenever you use events, you're using state. There's no way around it. Either that, or you're doing very little with events, like console logging something. You're always side effecting. That's bad, especially in large applications. Now, who is using that? There's a lot of buzz with reactive programming, but most of the frameworks that are out there are pretty new, not that much used in production, and kind of experimental. There's cool stuff. There's Facebook React. It's kind of reactive, but not really the same concept. There's Bacon.js. That's another FRP framework, same as RxJS. Some differences in the philosophy. It's pretty new. The cool thing about RxJS is that it's based on Rx. Netflix, the whole Netflix stack. Now on the server is running RxJava. On the client is running RxJS. If you use Netflix, that's Rx all happening. Microsoft, obviously, they created it. They use it on all kinds of projects. SoundCloud is using it. GitHub uses Rx Cocoa for their Mac app and Rx.net for their Windows app. So it's very solid. It's very stable. Real companies are using it, and they are benefiting from it. While everybody is dealing with crazy asynchronous models and trying to tame the asynchronicity of it all, RxJS makes it much, much easier. And I think that's all I've got for today. So thank you very much. I don't know if there's any questions. Yes. The question is, how would UIs or MVC, for example, work with RxJS? The way to think about stuff is what is reacting in the model view controller. The view is reacting. Probably the controller is more producing values. So basically, the view subscribes to controller in that case. Controllers are observables. Whatever, I don't know, the user makes the model, yeah. The controller will, the model will be an observable, the controller will observe the model, and the view will observe the controller. That's how it should work. Then, what I didn't talk about in the talk, there's another kind of entities called subjects, which inherit from both observable and observers, so they can do both at the same time. Then the model, in that case, would be one of those, because it will, the view can change the model. So it will be kind of a circle of listening and reacting to each other. I think that's from the top of my head right now. All right, then I think that's it. Thank you very much.